Welcome to Brain Vision.
In this problem, a block of ice released from rest at the top of a 1.50 meter long frictionless ramp slides downhill, reaching a speed of 2.50 meter per second at the bottom. Using this, we have to find out the angle between the ramp and the horizontal. So let us suppose the angle is theta. Now the forces acting on the block will be normal force by the ramp in the direction perpendicular to ramp and gravitational force in the downward direction. Now the angle of gravitational force with the direction perpendicular to ramp will be theta, which is same as the angle of the ramp with the horizontal. So the component of gravitational force perpendicular to ramp will be mg cos theta, and the component of gravitational force parallel to ramp will be mg sin theta. Now along the ramp we have only one force, mg sin theta, so acceleration along the ramp will be force upon mass, so acceleration is g sin theta. Now we will use the equation of kinematics, Vf square equal to Vi square plus 2As for motion along the ramp. Final velocity is 2.50 meter per second. Initial velocity is 0 at the top of the ramp. Acceleration is g sin theta and s is the displacement. From this we get sin theta equal to gs. Now g is 9.8 and s is the displacement along the ramp, 1.50 meters. So from this equation we get theta equal to 12.3 degrees. Now for part B we have to find out the speed of the ice at the bottom if motion is opposed by a constant friction force of 10 Newton parallel to the surface of a ramp. So now in this case we will have additional force of friction force up the ramp. So now the net force along the ramp will be mg sin theta minus friction force, and this will be equal to mass times acceleration. So acceleration will be g sin theta minus friction force upon mass. G is 9.8 and theta is 12.3 degrees. Friction force is 10.0 Newton and mass is 8.00 kilogram. So acceleration in this case is 0.833 meter per second square. Now we use equation of kinematics. Initial velocity is 0, acceleration is 0.833 and displacement is 1.50 meters. So the final speed at the bottom is 1.58 meter per second. This is the required solution. Thank you.